Spinning 3D printer could be key to stronger materials. Researchers from Harvard have developed a way to make 3D printed objects more durable, but the technique works with the same plastics already used in consumer machines. It turns out making a stronger 3D object is as much about the empty space as the plastic structure. Using a new rotating print head, the team has managed to precisely control the arrangement of microscopic fibers and give the finished object greater strength relative to its mass. When you print something with a consumer 3D printer, modifying the infill percentage and geometry can allow for a stronger part. It's like adding structural supports inside an object by depositing marbled medium in a given area. You can think of rotational 3D printing as a more advanced version of the same process with better results using less material. Biological materials often have much better mechanical properties than we can create via an artificial process. They can be stiff or flexible, with a strength per unit of mass that makes them efficient. All these properties would be desirable in synthetics, and rotational printing might get us there. The fibers in these new objects are oriented in a more natural way to improve the design's mechanical properties. While traditional printers use the same infill settings throughout an object, rotational printing is intended to tweak microstructures and give designers more control over the final product's properties. The rotating print head isn't just for show. As the print head spins, it ejects streams of viscous ink in various directions. If an object needs added mechanical strength in a specific area, the fibers can be nudged to provide that without adding to the weight as much as traditional methods. This all happens in the design phase by merely identifying load-bearing and high-stress regions of the object. The rotational printer does all the heavy lifting. The fibers are aligned within the build material, which could be almost anything currently used in industrial and consumer printers. The researchers claim rotational printing is compatible with fused filament fabrication, direct ink writing, large-scale additive manufacturing, and with materials like thermoplastic, glass, and carbon fiber. The current test printer works with an epoxy composite matrix. 3D printing hasn't taken off in the consumer space like many in the industry had hoped, but it's still important in manufacturing and design work. Rotational printing could allow for the production of longer-lasting materials that help push 3D printing to a broader audience. Now read PC Mag's best 3D printers of